There are moments when the universe reveals something unexpected. It presents a quiet wonder that asks us to simply look up. Today, on October 26, 2025, we find ourselves at such a moment. Our planet, Earth, is about to welcome a new companion. It is a small world, an asteroid. It has been given the designation 2025 PN7. For the next 83 years, this tiny object will trace a path around us. It will become a temporary faint moon in our sky. It is a remarkable and rare event, a celestial visitor that has chosen to stay with us for a while. It offers us a unique opportunity to study the cosmos up close. This new arrival is not a grand, dramatic entrance. It is a subtle shift in the celestial mechanics of our local neighborhood. 2025 PN7 is small. It will not light up our nights like our familiar moon. It will not pull upon our oceans. It will not alter our seasons. Instead, its presence is a gentle one. It is a reminder that the solar system is not a static, clockwork mechanism. It is a dynamic and ever-changing place. Objects are constantly in motion. Their paths are woven together by the silent, persistent force of gravity. And sometimes, just sometimes, one of these wandering bodies is drawn into our embrace. The story of 2025 PN7 is a story of gravity, timing, chance, every discovery with a single point of light. The story of 2025 PN7 is no different. It was found not with a sudden flash, but through the patient, methodical work of automated sky surveys. These are robotic telescopes, their digital eyes turned permanently toward the heavens, their sole purpose to watch for anything that moves against the fixed backdrop of the stars. In early August of 2025, Pan-STARRS in Hawaii captured a series of images of a mundane patch of sky. Images taken minutes apart were fed into powerful computers for analysis. The software is programmed to search for anomalies for tiny specks that shift their position from one frame to the next. Amongst millions of stationary stars, the algorithm flagged one moving dot. It was incredibly faint, just a handful of pixels, and moving in a way that suggested it was very close to Earth. That detection triggered an alert automatically sent to the Minor Planet Center. This is the standard protocol for any potential near-Earth object, or NEO. Once the alert was issued, astronomers around the world turned their telescopes toward the coordinates. They needed more data to confirm the object's existence and to calculate its orbit. Over the next several nights, observatories from Arizona to Chile to Spain tracked the faint speck. Each new measurement refined our understanding of its trajectory. The data slowly revealed a startling picture. This was not just another asteroid passing by. Calculations showed its path was being captured by Earth's gravity, entering a stable, albeit temporary, orbit around our world. After confirmations, the object was given its official designation, 2025 PN7. The name is a code. 2025 marks the year of discovery. P indicates the first half of August. N7 is a sequence marker for that period. It's a functional, scientific name for a profoundly fascinating object. The discovery wasn't one person's lucky glance, but the success of a global, collaborative system built over decades. It is a testament to human ingenuity and our enduring quest to map the heavens. So, what exactly is this new companion of ours? 2025 PN7 is what astronomers call a near-Earth asteroid. It is a small, rocky body, a leftover piece of the raw material that formed our solar system some 4.5 billion years ago. Based on its brightness and distance, scientists estimate its size to be quite modest. It is likely just a few dozen meters in diameter, perhaps the size of a large building or a small sports field. This makes it far, far smaller than our primary moon, which is a colossal 3,474 kilometers across. This is why we call it a mini-moon. From what we can gather so far, 2025 PN7 is probably a C-type asteroid. This is the most common type in our solar system. The C stands for carbonaceous, meaning its surface is rich in carbon compounds. This makes it very dark, like a lump of coal. It reflects very little sunlight, which is one reason why it was so difficult to detect. Its shape is likely irregular, not a perfect sphere like a large planet. Billions of years of drifting through space, perhaps enduring minor collisions, would have left it looking more like a jagged, tumbling potato than a smooth marble. Unlike our massive moon, the gravitational pull of 2025 PN7 is minuscule. If you could stand on its surface, you could likely jump into orbit with a single leap. Its tiny mass means it will have no discernible effect on Earth. It will not cause tides, nor will it perturb the orbit of our main moon or any of our artificial satellites. It is a silent passenger, its presence felt not through gravity, but through the light it reflects. It is simply there, a piece of primordial space rock that has been temporarily caught in our planet's gravitational well. As it spins, the amount of light it reflects back to us will change. By measuring these subtle variations in brightness over time, scientists can create what is called a light curve. This data can tell us how fast the asteroid is rotating and give us clues about its general shape. Is it long and thin, or more compact and blocky? These are the first, simple questions we can answer from afar. Each piece of information, no matter how small, helps us build a more complete portrait of this new celestial neighbor. It is a process of getting to know our visitor, one photon at a time. The journey of 2025 PN7 into Earth's orbit is a beautiful example of celestial mechanics. It is not a simple, circular path like the one our moon follows. Instead, it is a complex, looping trajectory, often described as a horseshoe or kidney bean shape. This path is the result of the gravitational interplay between three bodies: the Sun, the Earth, and the asteroid itself. For an object to be captured as a mini-moon, it must approach Earth with just the right speed and angle. If it is too fast, it will fly right past. If it is too slow, it might fall into our atmosphere. 2025 PN7 threaded this cosmic needle perfectly. Its orbit is not stable in the very long term. This is why it is only a temporary visitor. The gravitational pulls of the Sun and our own large moon will constantly tug on the small asteroid. These perturbations will slowly deform its orbit over the decades. Computer simulations model these gravitational forces with incredible precision. The models show that after approximately 83 years, these accumulated pulls build up, giving 2025 PN7 the gentle nudge it needs to escape Earth's gravity and re-enter an independent orbit around the Sun. Where did 2025 PN7 come from? It is highly likely that it originated in the main asteroid belt, the vast repository of rock and ice, located between the orbit of Mars and Jupiter. Over millions of years, Jupiter's gravity can disturb the paths of asteroids in this belt, sending them into the inner solar system. Some of these become near-Earth asteroids, their orbits crossing that of our own planet. 2025 PN7 was one such wanderer, drifting through our region of space for millennia until this chance encounter brought it into our fold. This 83-year period of captivity is, in cosmic terms, the blink of an eye. Yet for us, it is a human timescale. It is a span of time that allows for entire careers to be dedicated to its study. A scientist who begins observing it today could be training the next generation of astronomers to watch for its departure in the early 22nd century. For most of humanity, the arrival of 2025 PN7 will be an invisible event. You will not be able to simply walk outside and see a new moon with your unaided eye. It is far too small and dark for that. At its brightest, it will appear as a faint, star-like point of light only visible through a good pair of binoculars or a small amateur telescope. Even then, you will need to be away from the light pollution of cities under a dark, clear sky. You will also need to know exactly where to look, using star charts or astronomy apps updated with its precise orbital data. What observers will see is motion. If you watch it through a telescope for several minutes, you will be able to detect its slow but steady crawl against the background of distant stars. This movement is the telltale sign that you are looking at an object within our own solar system. Astrophotographers will be able to take long exposure images that reveal its path as a faint streak of light. Capturing an image of 2025 PN7 as it passes near a familiar constellation or a bright planet will become a popular challenge for sky watchers around the globe. The visibility of our mini-moon will change over time. Its complex orbit means that its distance from Earth will vary. There will be periods when it is closer, and therefore slightly brighter, offering better viewing opportunities. At other times, it will be farther away, becoming so faint that only professional observatories can track it. Astronomers will publish forecasts, letting the public know the best dates and times to try and spot it. These viewing windows will become small, special events for astronomy clubs and backyard stargazers everywhere. It is important to manage our expectations. This will not be a spectacular sight like a bright comet or a meteor shower. Its beauty is more subtle. It lies in the knowledge of what you are seeing, a tiny, captured world, a temporary moon that has traveled for billions of years to spend a few decades with us. The act of finding it, of seeing that faint dot move with your own eyes, is a profound connection to the scale and motion of the cosmos. It is, a personal moment of discovery, available to anyone with a little patience and a clear view of the night sky. So, as we stand on the cusp of this new chapter in our sky's history, a simple question arises. What does it mean to have a new moon, even a temporary one? It means we have a new story to tell, a new point of light to seek out on a clear night, and a new connection to the vast universe that surrounds us. This small, rocky world, journeying with us for a while, invites us to renew our sense of wonder. It encourages us to look up from our busy lives and contemplate the grand cosmic dance of which we are a part. It's pretty special. For the scientific community, the arrival of 2025 PN7 is an extraordinary gift. Near-Earth asteroids are objects of immense interest. They are pristine remnants from the birth of our solar system, holding clues about the conditions and materials that existed when the planets were forming. Studying them is like cosmic archaeology. However, they are usually difficult and expensive to reach, requiring complex missions to chase them down as they speed through interplanetary space. 2025 PN7 is different. It has come to us, and it is staying. The asteroid's stable, nearby orbit makes it a comparatively easy target for a robotic mission. A space agency could launch a small, relatively low-cost probe to rendezvous with it. Such a mission would be far less demanding in terms of fuel and time than a trip to an asteroid in a distant solar orbit. A probe could fly alongside the mini-moon, mapping its surface in high resolution, with cameras, with radar. It could use spectrometers to analyze the composition of its rock, telling us precisely what it is made of. We could finally confirm if it is indeed a carbonaceous asteroid. An even more ambitious mission could attempt to land on its surface. Because of its tiny gravity, a landing would be more like a gentle docking maneuver. A robotic lander could drill into the asteroid, collect a sample of its material. This sample could then be returned to Earth for analysis in our most advanced laboratories. This would be a scientific treasure trove. It would allow us to study a primitive piece of the solar system with a level of detail that is impossible to achieve with telescopes alone. We could search for water, organic molecules, other building blocks of life. The 83-year duration of its orbit gives us time. We do not need to rush. Space agencies can develop and test new technologies. We can plan a series of missions, each building on the knowledge of the last. Perhaps the first mission will be a simple flyby, followed by an orbiter, and then a sample return. The long stay of 2025 PN7 allows for a thoughtful, multi-generational program of exploration. It is a perfect testing ground for the techniques we will need to explore other asteroids in the future, including those that might one day pose a threat to our planet. Well, it's quite a story. Whenever a new object is found near Earth, one of the first and most important questions is it dangerous? It is natural to feel a sense of apprehension about a rock from space entering our planet's gravitational domain. However, in the case of 2025 PN7, the scientific consensus is clear. Based on all current observations and orbital calculations, this mini-moon poses no threat of impact to Earth. Its orbit, while complex, is well-defined and does not intersect with our planet. It will remain a companion, not a danger. Scientists at space agencies NASA ESA maintain a constant watch on all near-Earth objects. This is the purpose of programs dedicated to planetary defense. They use a global network of telescopes to track these objects, refining their orbits with every new observation. For 2025 PN7, this monitoring will be continuous throughout its 83-year stay. Any tiny deviation from its predicted path would be detected very quickly. This vigilant watch ensures that our understanding of its trajectory remains highly accurate, providing us with certainty about our safety. But what if an object like 2025 PN7 were on a collision course? It is important to understand the scale. An asteroid of this size, a few tens of meters across, would not cause a global catastrophe. If it were to enter our atmosphere, it would most likely break apart and burn up at a high altitude. This would create a spectacular bright fireball in the sky, known as a bolide, and potentially an airburst that could shatter windows on the ground below. It would be a significant local event, but not an existential threat. The discovery and tracking of 2025 PN7 is actually a success story for planetary defense. It shows that our systems are working. We are capable of finding these small objects, calculating their paths, and assessing any potential risk long before they come close. This mini-moon, in its harmless orbit, serves as a valuable exercise. It allows scientists to practice and refine their tracking and characterization techniques on a real, live target. It helps us become better prepared for the day we might discover an object that does require a more serious response. For now, we can observe 2025 PN7 not with fear, but with scientific curiosity. A new moon, even a tiny one, is more than just a scientific curiosity. It is a cultural event. It has the power to capture the human imagination and inspire us in countless ways. Throughout history, the heavens have been a source of myth-art storytelling. The arrival of 2025 PN7 will surely continue this ancient tradition. We can expect artists to paint its imagined surface, musicians to compose songs about its lonely journey, writers to weave it into new stories of science fiction and wonder. It offers a new symbol in our collective sky. This mini-moon will also be a wonderful tool for education. Teachers in schools, teachers in universities can use it as a tangible example to explain complex concepts like gravity orbits the structure of the solar system. Instead of talking about abstract principles, they can point to a real object in our sky. School projects can be designed around tracking its position. Students can learn to use telescopes, analyze real astronomical data. It has the potential to spark an interest in science, technology, engineering, mathematics. It will also become a part of our shared conversation. People will ask questions. They will look up at the night sky with a renewed sense of curiosity. Museums, planetariums will create new exhibits to explain its story. Documentaries will be made. The name 2025 PN7, while scientific, may eventually be joined by a more popular, informal name given to it by the public. This process of naming and storytelling is how we make sense of our world and our place within it. This small asteroid gives us a new character in the grand narrative of our relationship with the cosmos. This shared experience can be a unifying one. In a world often divided, the sky is something we all have in common. Looking up at the same moon, the same stars, and now the same mini-moon connects us. It reminds us that we all live on a small, fragile planet, traveling together through the vastness of space. The quiet presence of 2025 PN7 for the next 83 years can serve as a gentle, persistent reminder of this shared identity and our common destiny as inhabitants of planet Earth. It is a focal point for our collective sense of awe. The story of 2025 PN7 is a story of impermanence. For 83 years, it will be our close companion, a fellow traveler around the sun. We will have time to get to know it, to study it, to be inspired by it. But its visit is temporary. In the early years of the 22nd century, around 2108, gentle gravitational nudges from the sun and moon will set it free. It will drift away from Earth. Its looping orbit will unravel. It will become just another asteroid on its own lonely path. Its departure will be as quiet as its arrival. There will be no grand farewell. It will simply fade from our telescopes as it moves farther away. But it will not be forgotten. The knowledge we gain will remain. The data from telescopes and robotic probes will be studied for decades. The photographs, the stories, the inspiration it provided will become part of our history. It will be remembered as the mini-moon that stayed with us at the turn of the 21st century. The visit of 2025 PN7 reminds us everything is in motion and everything changes. Planets form, stars are born, stars die, galaxies collide. Our solar system is not fixed and final. It is a dynamic place where small worlds can be captured and released. We are privileged to live when we have the technology and understanding to witness this. It is a rare opportunity to watch celestial mechanics unfold in human time. As we begin this 83-year acquaintance, let us do so with calm, hopeful curiosity. This small, dark rock is a messenger from the early solar system, and it has a great deal to teach us. It is a new point of light that invites us to look up and to wonder. It is a fleeting companion that reminds us to cherish the present moment. For a short while, in cosmic terms, we have a new moon. And that is a wonderful thing.